According to the National Electrical Code, Section 300.15 splices within the enclosure of an electrical distribution panel are permitted if specific conditions are met. Firstly, the splice must be made with an approved splicing device. The term approved refers to equipment that has been evaluated by a recognized testing laboratory and found suitable for a specific purpose or application. These devices are designed and tested to ensure reliable electrical connections and to prevent hazards such as overheating or short circuits. Secondly, the splice must be accessible for inspection and maintenance. This means the splice should be located where it can be easily inspected and accessed for any necessary maintenance or repairs without requiring significant disassembly or disruption of other components. Accessibility is crucial for ensuring the ongoing safety and reliability of the electrical system. Thirdly, the splice must be installed in a location that does not obstruct the operation of any equipment or circuit. The placement of the splice should not interfere with the normal functioning of other components within the panel. For example, it should not block access to circuit breakers, impede ventilation, or create physical obstructions that could compromise the performance or safety of the equipment. Underwriters Laboratories 508A, the standard for industrial control panels, does not explicitly prohibit splices within the enclosure of a panel. However, it requires that all connections and terminations be made in accordance with the National Electrical Code. Therefore, the National Electrical Code requirements also apply to splices within Underwriters Laboratories listed electrical distribution panels. In summary, splices within the enclosure of an electrical distribution panel are not prohibited, provided that they meet the specific requirements outlined by both the National Electrical Code and Underwriters Laboratories standards. These requirements include the use of approved splicing devices, accessibility for inspection and maintenance, and installation in a location that does not obstruct the operation of any equipment or circuit. Considering other relevant sections of the National Electrical Code helps to provide a more comprehensive understanding. Section 110.3b of the National Electrical Code requires that all equipment be installed and used in accordance with the instructions included in the listing or labeling. This means that any splicing device used within an electrical panel must be installed according to the manufacturer's instructions. This ensures that the device is used correctly and safely. Section 312.8 of the National Electrical Code addresses the use of enclosures for splices and taps. It specifies that enclosures for splices and taps must provide adequate space and protection for the conductors and splices. The enclosure must also be suitable for the environment in which it is installed, such as being weatherproof if installed outdoors. Section 408.3e of the National Electrical Code requires that panel boards be installed in cabinets or enclosures. These enclosures must be securely mounted and provide adequate protection for the panel board and its components. Any splices within the panel board enclosure must comply with the requirements of Section 300.15 Section 314.16 of the National Electrical Code specifies the number of conductors allowed in outlet, device, and junction boxes. This is important for ensuring that the box is not overcrowded, which could lead to overheating or other problems. When making splices within an electrical panel, it is important to consider the number of conductors in the enclosure and ensure that it complies with these requirements. Section 314.17 of the National Electrical Code covers the methods for entering and exiting boxes, conduits, or fittings. It specifies that conductors must be protected from abrasion and that any openings must be properly sealed. When making splices within an electrical panel, it is important to ensure that the conductors are properly protected and that any openings are sealed to prevent the entry of moisture or other contaminants. Section 314.28 of the National Electrical Code provides requirements for pull and junction boxes. This section is relevant when the electrical panel serves as a pull or junction box for conductors. In these cases, the size and construction of the panel must comply with the requirements of Section 314.28. Section 408.41 of the National Electrical Code specifies the requirements for the overcurrent protection of panel boards. This includes the type and size of circuit breakers or fuses used to protect the panel board and its circuits. Any splices within the panel board must be made in a way that does not compromise the overcurrent protection of the circuits. Section 408.55 of the National Electrical Code covers the marking of panel boards. This includes the identification of circuits, the voltage and current ratings of the panel board, and other important information. Any splices within the panel board must be made in a way that does not obscure or interfere with these markings. UL 500A provides additional guidance on the construction and testing of industrial control panels. Section 7.2 of UL 500A covers wiring methods. It specifies that wiring within the panel must be neatly arranged and securely supported. Any splices within the panel must be made in a way that does not create a hazard or interfere with the operation of the equipment. Section 18 of UL 500A covers connections. It specifies that all connections must be made in a reliable manner and that they must be able to withstand the stresses and vibrations of normal operation. Any splices within the panel must meet these requirements. Section 23 of UL 500A covers spacing. It specifies the minimum spacing requirements for components within the panel. This is important for preventing arcing and other electrical hazards. Any splices within the panel must be made in a way that does not violate these spacing requirements. In addition to the specific requirements outlined in the National Electrical Code in UL 508A, there are also general safety considerations that should be taken into account when making splices within an electrical panel. Firstly, always to energize the circuit before working on any electrical equipment. This is the most important safety precaution to prevent electric shock. Secondly, use appropriate personal protective equipment, such as gloves and safety glasses. This will help to protect you from electrical hazards and other injuries. Thirdly, inspect all tools and equipment before use to ensure that they are in good working condition. Damaged or faulty tools can create a safety hazard. Fourthly, follow the manufacturer's instructions for all splicing devices and materials. This will ensure that the splice is made correctly and safely. Fifthly, ensure that the splice is properly insulated to prevent short circuits and other electrical hazards. Sixthly, secure the splice in a way that prevents it from coming loose or being damaged. Seventhly, label the splice to identify the circuit and the date it was made. This will help with future maintenance and troubleshooting. Eighthly, document the splice in the electrical panel's documentation. This will provide a record of the splice and its location. Ninthly, inspect the splice regularly to ensure that it is still in good condition. Tenthly, if you are not comfortable making splices within an electrical panel, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to have it done by someone who is trained and experienced. Common mistakes to avoid when making splices within an electrical panel are using the wrong type of splicing device. Different types of splicing devices are designed for different applications. Using the wrong type of device can lead to a poor connection and potential safety hazards. Over-tightening or under-tightening the splicing device. Over-tightening can damage the conductors and the device. Under-tightening can result in a loose connection. Not properly insulating the splice. This can lead to short circuits and other electrical hazards. Overcrowding the enclosure with splices. This can make it difficult to access the splices and can also create a fire hazard. Not labeling the splices. This can make it difficult to identify the circuits and can also create confusion during maintenance. Not documenting the splices. This can make it difficult to track the splices and can also create problems during future inspection. Ignoring manufacturer's instructions. This can lead to improper installation and potential safety hazards. Neglecting safety precautions. This can result in electric shock or other injuries. Failing to inspect the splices regularly. This can allow problems to develop and can also create a safety hazard. Avoiding these common mistakes will help to ensure that the splices within an electrical panel are made safely and correctly. It's also important to understand the types of splicing devices that are approved for use in electrical panels. Wire connectors, commonly known as wire nuts, are a type of splicing device used to connect two or more wires together. They consist of a plastic cap with a tapered, threaded metal insert. The wires are twisted together and the wire connector is screwed onto the twisted wires to create a secure connection. Wire connectors are available in various sizes to accommodate different wire gauges and numbers of conductors. Crimp connectors are another type of splicing device used to connect wires. They consist of a metal sleeve that is crimped onto the wires to create a mechanical and electrical connection. Crimp connectors are typically used for larger wire gauges and for applications where a more secure connection is required. They require a special crimping tool to install. Terminal blocks are used to provide a convenient and organized way to connect wires within an electrical panel. They consist of a series of individual terminals, each with a screw or spring clamp for securing the wires. Terminal blocks are often used for connecting control wires, instrumentation wires, and other low-voltage circuits. They are available in various sizes and configurations to accommodate different wiring needs. But splices are used to connect two wires end to end. They consist of a metal sleeve with an insulated barrel. The wires are inserted into the barrel, and the sleeve is crimped onto the wires to create a secure connection. But splices are typically used for repairing damaged wires or for extending the length of a wire. Split bolt connectors are used to connect two or more wires together. They consist of a threaded bolt with a split nut. The wires are inserted into the split nut and the bolt is tightened to create a secure connection. Split bolt connectors are typically used for larger wire gauges and for applications where a high current carrying capacity is required. Insulated tap connectors are used to tap into an existing wire without cutting it. They consist of a plastic housing with a metal contact. The tap connector is clamped onto the existing wire, and the new wire is inserted into the connector and secured with a screw or spring clamp. Insulated tap connectors are often used for adding new circuits to an existing electrical panel. When selecting a splicing device, it is important to consider the following factors: the wire gauge, the number of conductors, the voltage and current rating, the environmental conditions, and the applicable codes and standards. Choosing the right splicing device for the application will help to ensure a safe and reliable electrical connection. The National Electrical Code in UL 500A provides specific guidelines for selecting and installing splicing devices. It is important to follow these guidelines to ensure compliance with the code and to maintain the safety of the electrical system. Splicing devices should be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, Canadian Standards Association, or Intertek. This indicates that the device has been tested and meets the applicable safety standards. The listing or labeling will also provide information on the device's voltage and current ratings, wire gauge range, and other important specifications. It is important to choose a splicing device that is rated for the voltage and current of the circuit in which it will be used. Using a device that is not properly rated can lead to overheating, insulation breakdown, and other electrical hazards. Splicing devices should be installed in accordance with the manufacturer's instructions. This will ensure that the device is properly connected and that the wires are securely held in place. The instructions will also provide information on the proper torque for tightening the screws or crimping the connectors. It is important to use the correct tools for installing splicing devices. Using the wrong tools can damage the device or the wires, and can also create a safety hazard. For example, crimping tools should be used for crimping connectors, and torque wrenches should be used for tightening screws to the proper torque. Splicing devices should be inspected regularly to ensure that they are in good condition. Look for signs of damage, such as cracks, corrosion, or loose connections. Replace any damaged devices immediately. When making splices within an electrical panel, it is important to keep the enclosure clean and free of debris. Dust, dirt, and other contaminants can interfere with the performance of the splicing devices and can also create a fire hazard. It is also important to keep the wiring neat and organized. This will make it easier to troubleshoot problems and to maintain the electrical system. Wires should be bundled together and secured with cable ties or other fasteners. They should also be labeled to identify the circuit to which they belong. In addition to the National Electrical Code in UL 508A, there may be other codes and standards that apply to splices within electrical panels. These may include local building codes, fire codes, and insurance requirements. It is important to check with the local authorities to determine which codes and standards apply in your area. Proper training and experience are essential for making safe and reliable splices within electrical panels. Electrical work can be dangerous, and it is important to have it done by someone who is qualified and experienced. If you are not comfortable making splices within an electrical panel, hire a qualified electrician to do the work.